This may or may not be in your quiz. You have a quiz next class that we'll meet, by the way. This may be written. Nonetheless, I want you to check your answers always. But I also want you to learn when and where you should check your answers and why you should check your answers. Because if you check your answers on every single problem, you may not have enough time to finish. Okay, here we go. What do you already notice different about this problem, guys? There's an x already by itself, but then there's another x, right? What's the power of this x? 1. And this one is dealt with as 1/2. It's dealt with that square root function piece. Okay? When we've been solving the other ones, we've tried to isolate the radical. That means whatever we did, our goal was to get it to look like something like this, where the square root was on one side and then the other numbers were on the other. Because ultimately from here, to pull this x out, we would square both sides. But this one's a little bit different. But nonetheless, let's see if we can still isolate the radical. Anyone, what do I do to isolate the radical? Add 5, right? Okay. Alright, here we go. I'm going to start calling on some people, and I want to hear what do you have as far as interpretation of what to do next. Okay, Charlie, we'll start with you. What do I do?
I would square both sides.
Square both sides, yeah. Square both sides. Charlie, when you do that, what's left over on the left side?
X plus 7.
X plus 7. Careful. What's left over on the right side?
Sorry, wait, no, 4. Oh yeah, so I was right. X squared plus 25.
Ooh. Who else raise your hand if you thought it was x squared plus 25? A lot of people do. A lot of people do. It's not that. You need to write in your notes, this is a perfect square trinomial, so PST, to where it's like a plus b squared is the same as a squared plus 2ab plus b squared. Because you should be looking at this like two binomials that are going to multiply that you're going to distribute fold out method with. So everyone, what should the right side equal? Yes. You are not alone. There's a lot of people that make that mistake. Okay, so please try to understand when not to do that. The big thing that it should tell you is that this is a multiplicity of 2, so you'll write it down 2 times. But this is the reason why it should tell you. You understand? If that was multiplication, if that looked like x times 5 raised to the power of 2, then you would apply it to each individual piece and get 25x squared. But when it's addition or subtraction, it's all about this multiplicity pull out that you do with those two binomials. Questions?
So, yes, whenever it's not a perfect square trinomial, can you still work it out like that and then you'll get the right answer? Like if it's just x squared plus 9.
Yeah, well, no matter what, if it looks like this, go to that. If this was written 3 times, you'd have 3 of them written off.
Yeah.
You see what I'm saying? Did that answer your question?
Never. No, I'm never.
Okay. Alright, so let's go to... Okay, so now we're here, guys. This is our running answer. Any suggestions on what to do next? Say again? Set it equal to 0. Yeah. So we're going to subtract this x over. We're going to subtract this 7 over so that you have x squared. Keep going, guys. What? Plus 9x equals, or is plus what? 18. Do you notice what we just did? We made a radical expression or a radical equation into a what? Quadratic. We made a radical equation or a radical function become a quadratic function so that we can solve for those possible x's. Guys, what are my factors? Yep, x plus 6, x plus 3. So what are my answers? negative 3 and negative 6. But we have to check. Then I want to see if you can tell me why here in just a bit. Okay, here we go. Let's do the smaller number first. We're going to check by putting negative 3 into our original equation where you see orange. Okay? So negative 3 plus 7. 4. Square root. 2 minus 5. Negative 3. So on the right side, so I'm plugging them in here and here to check. The right side I would plug in a negative 3. Is this a true statement? Yes. So negative 3 works. It is a solution. Now, we're going to try to plug in the negative 6 and check that with me. Here we go. Negative 6 plus 7 is 1. Square root of 1 is 1. Minus 5, negative 4. Is that equal to negative 6? No. Even though mathematically we got the answer, it didn't work. So we say that negative 6 is an extraneous solution. It's an extra answer that doesn't work. Okay? Extraneous. It didn't work when you checked it, but mathematically you were able to get it. So x is negative 3 is your only answer. On the quiz, please check for extraneous. Because if you say an answer is an answer and it's not, or vice versa, you say an answer is extraneous and it's not, those are points that are easy to lose. Okay. Who can tell me why you think we got an answer that didn't work? We did all the math. This is conceptual understanding now. Yes?
I think because when you have the radical of the half square, it only goes positive. But maybe if you plug in the negative on the graph, it would go towards the negative side, which doesn't exist on the graph.
Okay. So she's contemplating that she's looking at this function that was given of a square root, and she's saying, I have some positive that exists, but I don't have any negative that exists. So maybe some of these answers, positive or negative, may not work. You see what we're saying? And she's exactly right. What other reasons are there, though? Yeah. Okay. So look, no one said this before yet. He's saying over here, this is x to the power of 1. Could that be a reason why we only had one solution? I like your ideas, and I want to hear what you're thinking. It has something to do with that. But if it's 1, don't think that there would just be one answer. It doesn't correlate that way. But it does have something to do with the fact that this is x to the 1. Any other ideas out there? Okay, so this is the big thing. When you go to pre-cal next year, you're going to get all kinds of answers that will give you answers whenever you solve them all out just like this, but you're going to have a lot of extraneous solutions, and it's a little bit annoying, and the time you use to check this is pretty big. You know, you want to be efficient with your time and make sure that you're not wasting time on these problems. So how do you know when to check your answers? This is how you know. Compare their domains. I'm going to compare the domains of both of these functions. Can someone tell me what's the domain of this square root function? Now listen, all I care about is the parent function. That means that. What's the domain? Or x is greater than 0, right? Greater than or equal to 0. The domain for this one is 0 to infinity. What's the parent function here? Yeah, y equals x. Don't be afraid to make a mistake. Don't be afraid to be wrong. Y equals x is the domain of the one on the right side. Or it's the function. So the domain is all real numbers. You with me? If I were to give you a visual on this, just to help you out, the first one's domain started at 0 and went to infinity. Alright, so let's keep going. So the visual representation of the domain of this square root function would be 0 to infinity. The visual representation of the domain over here on this y equals x linear function would be all real numbers. If I compare these domains, are they the same? No. When the domains are not the same, that's when you check. If they are the same, don't waste your time. Whatever you get down here, all will be inclusive. Good stuff? Alright, yes?
So if there's not an x on either side, if it's only on one side, you don't even have to worry about checking the
You see that? If there was a number over here, the way the other previous problems were just numbers, you don't have to check your answers because you're just looking at one function. You're only dealing with one function. SAT, ACT love to test this. Okay, and a lot of people don't learn it. They just dismiss it, and they're like, I'll just plug and chuck and try to test this. You know what I mean? But a lot of times they like to test it on non-calculator, on the ones that are grid-ins where they're not multiple choice. So know how to check, where to check, and why to check. Okay, yeah.
Where did you get the linear function from?
The linear function is because our original equation, it was just an x all by itself on the right side. So I really have, when is this square root function equal or touching the linear function over here?
It's the two equations of the two sides.
Yeah. So, and you can look at it that way. I love to do the algebra with stuff. I don't necessarily love to look at graphs, but we need to be strong at it. But ultimately, when you get to calculus, all this algebra that we've done, that's what you do in calculus. You don't go to this and say, okay, my original function on the left side is a square root function that's shifted 7 to the left and 5 down. So it looks like that somehow. And then my other function is x, and wherever they would cross is where my answer would locate. You see what I'm saying? So on this, you can see, let me go back just a little bit. If I were to have drawn this a little bit better, it looks like it would look like that. And then this one would kind of do like that. To where at -3, that's when my only answer would have occurred that they would have hit. Do you understand? Okay, but again, and I love the questions. I always love 7th period's questions. As far as the easiest way to identify is to look at their domains and compare their domains. If they're not the same, check your answers, because some may be extraneous. Cool? So let's do the next one. So that was a little bit more involved, talking about extraneous checking. You guys were awesome to do all that. We're going to do this again, just for practice, speed it up a little bit. So everyone, what do I do to both sides first? Oops. Say again? Subtract the 3. So when I subtract the 3, I have something that looks like this. Okay, everyone, what's the next step? Square it. The left side becomes 5x minus 1. The right side, careful, becomes minus 6x. Whoops. X squared minus 6x. What was that last part? Plus 9, yes. Because it's a negative times a negative. A perfect square trinomial. If you have to do it on the side, show the work, please do so. I'd rather you get it correct and not miss it by negatives and whatnot. Yep, subtract 5x, add 1, set it equal to 0. Guys, why do we set these equal to 0? There's nothing left, you're right, but I don't necessarily have to set it equal to 0. I mean, I could set it equal to something else. 0 is the correct answer, by the way. I need to set it equal to 0, but why? These are the x-intercepts, and because here we should be looking at it as what kind of functions? Quadratic. These are quadratic functions, which we're looking at when is this function equal to 0. Okay, so making sure that you understand with quadratics, that's when you're setting it equal to 0. So finish it off, guys. It's x squared equals what? Or sorry, x squared minus 11x plus 10. So the factors are what?
X minus 10 and x minus 2.
Yep. X minus 10, x minus 1. Good speed on that. If you're struggling a little bit, remember, you can't forget factoring for the rest of your math careers. Anytime you are doing math for the rest of your life, you can't forget factoring, okay? So this and these will multiply to get those following. And then you have a negative 10, negative 1 to add to get the negative 11. So everyone, what are my x answers?
Positive 1 and positive.
Positive 1 and 10. Well, we got to check. Why do we have to check them? We have different domains. We have one that is from 0 to infinity-ish, from the default parent function of square root of x. And then we have this other one, which is what? Yep, negative infinity to infinity, or all real numbers. They're not the same, so we have to check. Alright, so let's plug in 1. Again, please don't plug in 1 into any of this intermediate work. Don't. Because it will work. We need to plug it into the original one way up here. Alright, so here we go. 5 minus 1, 4 square root, plus 3, 5. What's the right side? Nowhere even close to 5. Right? So 1 is what? Extraneous. And don't just erase it on your answer. You have to state x equals 1 is extraneous. Okay? Don't just erase it. Because I'll ask you, what are the extraneous answers? What are the real solutions? Okay? So let's do 10. 50 minus 1, 49 square root. 7 plus 3, 10. Does 10 equal 10? Yep. So 10 worked. Good? Alright, so we'll do one more example, then we'll go eat. Okay, so 12:09, right? Okay. Here's where it gets involved. These are the involved ones, okay? They're not bad. Once you see it, you experience it, the pain for a couple of problems, maybe 3 or 4, then you're like, okay, that's not bad. What has been the step that we've been doing before? We've been isolating the radical. We can't do that here because we have 2 radicals. And someone said, well, can't we just put everything as 1 radical and do like this? They're not glued together by multiplication. If it was multiplication instead of this subtraction, then by all means, you could do that. But you can't do that rule on this right here. Nice. Okay? So, what do y'all suggest? Square both sides right now, right? Some people are saying square both sides right now. All my periods have been saying that, which is, hey, I would probably do the same thing because I'm thinking like conjugate pairs and stuff like that. So here we go.
So should we not do it?
Well, I need you to see why, though, because when you do it, it's easy to follow me. But when you do it on your own, you need to see why you don't do certain things at certain times. Okay? So if I have this, and I'm squaring it, multiplicity of 2. Okay, let's do this together. This is going to build this huge kind of trinomial to where if I first multiply these, what would I have? 2x plus 1. And good practice would be to leave it in a form of parentheses of some kind. Okay? Then we know the last term would be a what? positive x. And this is what you need to experience now. Is that this b term, if you will, do you see what's happening right now? It's going to be minus 2 of these. Which, if you wanted to say it like 2x plus 1, because they are now glued with multiplication, you could do it like that. Do you see how it really didn't help? It created a new square root, and this square root's a little bit involved. Like, there's more to this. You with me? Could you solve it out from here? You could. But I think this is a little bit too involved right now. But it still would work. It's just a little bit nightmarish to look at it. So, let's try moving this so that we have something that looks like this. You with me? Now square both sides. 2x plus 1 is left over here. Over here is 2 of these, which I'm the kind of guy who would need to write it at your age. And that's okay. 1 plus 2 of these plus x would be what I would have on the right side. See how this new one was also created? But it's so much easier than the other one that was created. So if I move this one, move this x, I'm subtracting 1 and I'm subtracting x, I'm left with that. And guess what I do to finish this off? And then we'll go to lunch. Square both sides. This becomes 2 squared, and the square root of x squared, which is 4x. Again, it was applied to both of these bases. So you get 4x is equal to x squared. The mistake people would make from here is they would divide both sides by an x, and they would only get half of their answers. What we need to do is recognize when I have an a term and a b term from standard equation, I need to set it equal to 0. This is a common mistake in like pre-cal and calculus. I need to set it equal to 0 and Gcf factor. We're almost done. So set this equal to 0 by moving the 4 to the left. Now Gcf out an x so that I have 0 and 4. If I plugged in 0, I get 1 minus 0 is 1. 0 works. If I plugged in 4, I get 3 minus 2. 4 works as well. You with me? So they both ended up working. No extraneous. And because the reason why is I have just one function on the left. You know what I mean? If I would have moved it over to the right, I have a square root on the right, I have a square root on the left. The domains of their default parent functions are still going to match up. Yes?
Did you get this whole right side right here from that?
Yep. Yeah. All of this followed out to this.
No, I mean, no. Whatever.
Okay.
This is from, no.
Go to lunch, guys.